Exponentiation is raising one number to the power of another. But what happens when you put a number raised to itself? And what if you do that over and over again? This funny looking curve may look like some complicated polynomial, but it's actually just y equals x to the power of x. And this is one of the 4 graphs that I am going to explain today. My name is Ryan Itanio from Chitadi West, and my research is the power of x, visual analysis of exponentiation and tetration. So first, what is tetration? I know exponents, but what is this? Well, fundamentally, tetration is just repeating or stacking exponentiation. It's like how multiplication is just repeated addition. Ever thought of it that way? 2 raised to the height of 3 equals to 2 to the power of 2 to the power of 2, which equals 16. We can also reverse this with superlogarithm and super root functions. As you can imagine, tetration of a small number like 2 can produce really large results when you raise the height. The objectives of this research are to investigate the properties of tetration and the graphs of exponentiation and tetration. So first, I started by using formulas in a spreadsheet, but that was slow and hard to understand, so I turned to graphs, and I used apps like GeoGebra and Desmos to study and analyze. So let's go back to that first graph. When you find the derivative of y equals x to the power of x, you can get the minimum point, which is 1 over e comma e to the power of negative 1 over e. E is Euler's number, a special transcendental number like pi with value of around 2.7. Then when x is less than 0, that means we are actually raising a negative number to the power of another negative number. And because of how weird that is, the results can actually be positive, negative, or even imaginary. And this is what caused the holes in the graph. Next is y raised to x equals x raised to y graph. This shows the time where you can move around the numbers in exponentiation and the result is the same, called the commutative. But that doesn't always apply. It only applies at the integer solution of 2 and 4, as well as this curve, and also when y equals x, of course. And their intersection point is EE. This graph is also equivalent to y equals xx with a smaller intersection of 1 over e comma 1 over e. Next, we have the function x raised to the height of n. When we graph this, it turns out that all values of n, as it increases to infinity, the graph starts to look like a single curve at e raised to e until e raised to 1 over e. Past this point, the function increases to infinity. Next, we looked at when n is a fraction. Turns out we can rewrite the fraction and move it to the other side of the equation and also graph this as well. And this also converges at that same area. In conclusion, the minimum point of y equals x raised to x is 1 over e comma e raised to the power of negative 1 over e. The intersection of yx equals xy is at EE. And lastly, the curve in the graph of fx equals x raised to n heights converges as n approaches infinity. To close, I would like to leave you with a quote. If I have seen further, it is by standing on the shoulders of giants. Thank you.